Welcome to the Probability and Statistics course. Today's lesson is on confidence intervals for one sample. In our last lesson, we have seen how to construct a confidence interval for the mean. Now we are going to see in more details what happens with confidence intervals for mean, and also we are going to see confidence intervals for other characteristics of a population. In this lesson, we are going to talk about one sample. In our next lesson, we are going to talk about two samples. Now, we have avoided giving in detail how we can obtain the formulas we are going to see. We are just going to learn through examples how to use the formulas in practice. So, in this lesson, we have confidence intervals for one sample, for the mean, for proportion, another characteristic of the population. We are going to see exactly what this is. And finally, for the variance. We start again by giving the confidence interval for mean, which we saw in our last lesson. So, to remember, the 100 times 1 minus 8% confidence interval for the mean is, as we have seen, given here. Now, here we have assumed that the standard deviation is known. In the case where the standard deviation is unknown, then we have two cases. If n is large, that means actually that n is greater than 29, we replace the variance of the population, the standard deviation of the population, with the standard deviation of the sample. And so we have exactly the same formula as before, but whereas we had the standard deviation of the population, now we have the sample standard deviation. In the case that the standard deviation is unknown, but n is small, that means that is less than 30, then only in the case that we know, we have the information that the population comes from normal distribution, we have that, we can calculate the confidence interval for the mean from this formula here. Now, if we look closely, we see that this is very similar to that, the only difference being that the distribution here has changed. Here we had the standard normal distribution, the point of the standard normal distribution. Here we have the what is called t-student distribution. Now, for all these new distributions we are going to see when we construct confidence intervals, there are ready tables, statistical tables in books from which we can read the value we are looking for. So we are not going to spend any time giving more details about these distributions, as we can find everything ready in the statistical tables and just read the values and put them in our formulas. So here is the t-student distribution as it is called. Now the t-student distribution has one characteristic here, it's called the degrees of freedom, and the degrees of freedom will be n minus 1. Now, how degrees of freedom are calculated are not in the scope of this course. But what we have to know is that when we look, when we want to find a value in the statistical tables, we have to specify what degree of freedom, as it's called, we are looking. So when we construct confidence interval for the mean in this case, we are looking for degrees of freedom n minus 1, n are the data, the number of data we have. Let's see an example. So our data are the mean time of normal operation of a network. And we want to construct a 90% confidence interval of the mean of this data. Now the sample size is 45, which means it is a large size, it is large enough in order to use the first formula we have seen with using the normal, the standard normal distribution. We have that the sample mean, if calculated for the data are not given here, but we are given the information that the sample mean is 1762, and also the sample standard deviation of the data is 215. So now we are going to construct a confidence interval for the mean of the population. Let's see what we are going to do. As we said before, we can actually use the confidence interval for the mean with using the standard normal distribution and not the t-student distribution as the sample is large. Now, the standard deviation is unknown. We are not given what the standard deviation is, so we have to replace the standard deviation by the sample standard deviation. And we have that the confidence interval can be calculated by this formula here. So the most difficult thing when constructing intervals, confidence intervals, is actually to find out exactly which formula we need to use, in which of the cases we're going to see we are. So for this case, we can use this formula here. We have that the sample mean is given, the sample standard deviation as well, and so we can construct, as we know from our last lesson, our 100 times 1 minus a% confidence interval. Now we are asking for a 90% confidence interval. So doing the calculations here, we have that A is 0.1, and so we would be looking for Z, the value of Z, the point at 0.05 area. So this is, if we read it from the tables, 1.6454, and now we can replace this value in our formula, replace our S, replace our sample mean, and replace our N, which we know is 45. And so by doing the calculations here, we know that the sample, the confidence interval for the mean will be given if we do these calculations. 45 data. And this is actually this interval here. Now, I use this in order to distinguish with the comma here. This is an interval. Now we are going to see another example when our sample size is not large. So we have data, what the company paid, what commissions the company paid to 6 employees. The data are given in this table, and we have that it is reasonable to assume that the population follows normal distribution. That is because commissions, we assume that people, not a lot of people get a high commission, not a lot of people get a low commission, and there is a mean value where most of people, around which most of people are, let's say, symmetrically distributed the data. So we say that that is reasonable to assume. So let's now calculate the confidence interval for each data. We can use the t-distribution here as we have normally distributed data. We can calculate the sample mean and the sample standard deviation. We have learned how to calculate this from data. Now we want to find the 101 minus a% confidence interval. Let's assume that this is 90% we are looking for, and from here we have that a equals 0.1. So the point of the distribution we are looking will have, its characteristic will be that we have n minus 1 degrees of freedom as before a over 2, which is we have 6 data, so this is 5, and this will be 0.05. If we look at our tables, we can find this value of the t-student distribution. Now what we have is that actually our 90% confidence interval for the sample mean will be, as we have seen, will be given by the formula here. So we just need, as the standard deviation is unknown, we need to put the value of S to replace the value of n. N is 6 data, the value we have read from the tables, and actually find the confidence interval for the mean in this case. Let's see now for another characteristic of the population. we are going to see the proportion. Proportion is important when we are talking about public opinion polls. So public opinion polls report percentage or fractions of a group with a certain characteristic from the sample. If X are the number of elements in the group with the characteristic, then the proportion P can be estimated. The point estimator of the proportion P is given by X divided by N. And in this case, the confidence interval for the proportion in the case that N is large will be given here. It can be calculated using this formula. We see again that in the case that N is large, we can use the standard normal distribution. When N is small, the confidence interval for the proportion will be given by this formula here. Our estimator has changed, the estimator of the proportion has changed, and it has become X plus 2 over N plus 4. Now, we are going to see an example. We have data, 100 students that were asked if they are left-handed when they write or not, and we had yes, they answered yes, 14 out of 100. Now, an estimate of the proportion, we have a large sample, is given by X divided by N, 14 out of 100, 0.14. And now we are going to construct a confidence interval for the proportion. So we have that the estimate for this case is 0.14, and the confidence interval we are going to construct here is a 95% confidence interval. In this case, A can be calculated, it is 0.05, and so the point of the normal distribution, it will be at 0.025 is 1.96. And so the confidence interval, the 95% confidence interval for proportion is given by the estimate of the proportion, replacing the value of the normal distribution. We need to calculate the square root of this quantity here, and we have, if we do all calculations, that actually the confidence interval for the true value of the proportion is 0.105, 0.175, the 95% confidence interval. Now, let's see confidence intervals for the variance of a population. So, the 100 times 1 minus a% confidence interval for the variance. Now, when population is normally distributed, this is important here, it's given in this formula. Now, we note here, we see that there is a difference with other distributions they are used. Here we use the chi-square distribution. Chi-squared from the Greek letter chi, and again we can see there are degrees of freedom, n-1 degrees of freedom. Now, for this distribution, we have that the difference with the normal distribution, the t distribution we have already seen, is that this distribution is not symmetric. So we do not take the same area from one side and the same area from the other side. So that's why we can see here that from one side we are looking at the area a over 2, and for the other side 1 minus a over 2. So that's the important difference for this distribution from the other distributions we have used to calculate, to find confidence intervals. Now, for the standard deviation, of course, when again the population is normally distributed, will be the confidence interval of the variance, but we have to take the square root of what we have calculated. Now, let's work through example to see how we can calculate confidence intervals for the variance. We have that. Company paid the following commissions to 6 employees. Data are given here. Now, we do not know the variance. The variance is unknown. The standard deviation is unknown. And as we said before, it would be reasonable to assume for this data that the population follows normal distribution. Let's see how we calculate the confidence interval for the variance of this set of data. So, we have that. We calculate the sample mean, which is 1691.17, and the sample standard deviation given here. Now, the confidence interval we are looking for is the 90% confidence interval, for example, and we would have from here, if you do the calculations, that a over 2 is 0.05, and also now, as we said before, our distribution, the chi-square distribution, is not symmetrical, so we are not going to look at the minus a over 2 point but of the distribution, but we look at the 1 minus a over 2, which would be equal to 0.95. So now we can calculate from the tables we would be looking for the value of the chi-square distribution of n minus 1 a over 2, which for this set of data, it actually corresponds to 5. We have 6 data, and 0.05 as calculated here. And if we look at our tables, we can actually read the value of the chi-square distribution, which is 1107. Now we need to read the value of the chi-square distribution for area 1 minus a over 2, which will be (1 minus a over 2). For this case, 5.095, which is, if we read from the table this value, 1.14. Now that we know the values of the distribution, we can calculate the confidence interval. We have, for our example, the 90% confidence interval for the variance is, as we know, it can be calculated by the formula we rewrite here, x squared, and by substituting the values we have, what we obtain is the interval here and this. Now, we see that these values are very large, and of course this is expected. As we said, we are looking for the variance, and the variance is our squared unit of our numbers. We have already seen that our numbers are large, so we would expect that the variance would, the numbers would look very large like this. Now, it would be more reasonable if we calculate the confidence interval for the standard deviation, so that we actually look at units as we have our data. So, the confidence interval now, the 90% confidence interval for the standard deviation we can take the square root of the numbers we had before, and so the new confidence interval for the standard deviation will be 252.62 up to 1,760.27. Now, this confidence interval, these units, look more reasonable, look more close to the data we had. We see why the standard deviation is more preferable to work with rather than the variance. Now, let's have a look at the distributions, the two new distributions we've talked about, the t distribution and the chi-square distribution. Let's have a look at how the chi-square distribution first of all looks. We said that it's not symmetrical like the normal distribution. So, although depending on the degrees of freedom, the chi-square distribution would look different, in general, it looks most of the times look something like this. Now what happens here? Let's have a normal distribution to compare. As we have seen, a normal distribution is symmetrical. A chi-square distribution is not symmetrical. So here, the areas we calculate are not from point, they do not cover the area A over 2 and minus A over 2 the points, but as we said before, it will be A over 2 and 1 minus A over 2. We see also that this distribution, the chi-square distribution, is more pointy and skewed than the normal distribution. We can actually, with the data we have learned how we can calculate skewness and kurtosis to compare with the normal distribution. Now the t-distribution. How would a t-distribution look? A t-distribution looks more close to a normal distribution. It is symmetric as the normal distribution, but it's different than the normal for n small. What actually happens is that for n large, the t-student distribution looks like is almost the same as the normal distribution. And that explains actually our formulas. When n is large, where we have used the t-student distribution, we could actually use the normal distribution and obtain the same formula we have for n large. So we see how the two distributions, what they've got in common. The problem is when n is small. Then when n is small, we have a difference, big difference between the normal and the t-distribution. But they are both symmetrical. Now, what we have seen here, we have obtained confidence intervals for one sample. We have actually talked about one population. We wanted to find point estimators, and in this lesson confidence intervals when we are talking about characteristics of one population. But in our next lesson we are going to talk about two populations. We are going to talk about characteristics of two samples and how to make confidence intervals, to calculate confidence intervals in this case when we have two samples. So we have created a confidence interval for the mean, for proportion, and for the variance. Now, we've seen that for the mean and the proportion, the distributions used to calculate confidence intervals had the characteristic that they were symmetric, but we have to be very careful when we construct confidence intervals for the variance. The distribution used is not symmetric, so we have actually to read two values from our statistical tables, not just one, two different values. So for more information on this lesson, you can visit the webpage of Netuno MedNetU project.